NEC section 250.122c addresses the sizing of grounding conductors. This section states that grounding conductors must be sized in accordance with table 250.122 and shall not be smaller than the size required for the branch circuit conductors. This means that the grounding wire must be at least as large as the hot and neutral wires in the circuit. In your scenario involving a 30 amp circuit supplying power to swimming pool equipment, where you are using number 10 American wire gauge wires for the hot and neutral conductors, the grounding conductor must also be number 10 American wire gauge. Table 310.15b16 indicates that number 10 American wire gauge wire is suitable for a 30 amp circuit, considering typical insulation types and ambient temperatures. The purpose of a properly sized grounding wire is to ensure electrical safety. A grounding system is designed to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, in the event of a ground fault. If a ground fault occurs, such as a short circuit between a hot conductor and a grounded metal enclosure, a large current will flow through the grounding conductor. This high current will cause the overcurrent protective device to trip, interrupting the flow of electricity and preventing a potentially dangerous situation. Using a grounding conductor that is smaller than the circuit conductors could compromise the effectiveness of the grounding system. A smaller grounding conductor will have a higher impedance, which means it will offer more resistance to the flow of fault current. This can slow down the response time of the overcurrent protective device, increasing the duration of the fault and the potential for damage or injury. Furthermore, a smaller grounding conductor may not be able to safely carry the fault current without overheating. This could lead to the melting of the conductor's insulation, creating a fire hazard or further compromising the grounding system. In the context of swimming pool equipment, electrical safety is paramount. Swimming pools and surrounding areas are inherently wet environments, which increases the risk of electrical shock. Properly grounding all metal parts of the pool equipment, such as pumps, filters, and heaters, is essential to minimize this risk. If a ground fault occurs in the pool equipment, the properly sized grounding conductor will provide a low impedance path for the fault current to return to the source, tripping the overcurrent protective device and preventing electrical shock. Therefore, replacing the number 12 American wire gauge ground wire with a number 10 American wire gauge ground wire is necessary to comply with the NEC and ensure the safety of the swimming pool installation. It is also important to ensure that the grounding system meets all other applicable electrical codes and standards for swimming pool installations. This may include requirements for bonding all metal parts of the pool structure together, using ground fault circuit interrupter protection for receptacles and equipment, and maintaining proper separation between electrical equipment and the pool water. Always consult with a qualified electrician to ensure that your swimming pool electrical system is installed and maintained in accordance with all applicable codes and standards. In addition to the code requirements, there are several other factors to consider when selecting the size of a grounding conductor. Firstly, the length of the circuit is an important consideration. The longer the circuit, the greater the impedance of the grounding conductor. This is because the resistance of a conductor is directly proportional to its length. Therefore, for long circuits, it may be necessary to increase the size of the grounding conductor to compensate for the increased impedance. Secondly, the type of load being served by the circuit is another important consideration. Some loads, such as motors and transformers, can generate significant harmonic currents. Harmonic currents are currents that have frequencies that are multiples of the fundamental frequency of the power system, which is typically 60 Hz in the United States. Harmonic currents can cause increased heating in conductors, including the grounding conductor. Therefore, for circuit-serving loads that generate significant harmonic currents, it may be necessary to increase the size of the grounding conductor to prevent overheating. Thirdly, the ambient temperature in which the grounding conductor is installed is also an important consideration. The ampacity of a conductor, which is the amount of current that it can safely carry, decreases as the ambient temperature increases. This is because the conductor's resistance increases with temperature, which leads to increased heating. Therefore, for grounding conductors installed in high ambient temperature environments, it may be necessary to increase the size of the conductor to compensate for the reduced ampacity. Finally, a type of insulation used on the grounding conductor is also a factor to consider. Some types of insulation have a higher temperature rating than others. This means that they can withstand higher temperatures without degrading. Therefore, grounding conductors with higher temperature rated insulation can typically be used at higher ampacities than conductors with low temperature rated insulation. In summary, when selecting the size of a grounding conductor, it is important to consider all of the relevant factors, including the code requirements, the length of the circuit, the type of load being served, the ambient temperature, and the type of insulation used. Consulting with a qualified electrician is always recommended to ensure that the grounding conductor is properly sized for the application. The inspector is correct in requiring a number 10 American wire gauge ground wire for the 30 amp circuit. This is because NEC section 250.122c mandates that the grounding conductor be at least the same size as the circuit conductors, which are number 10 American wire gauge in this case. Using a smaller ground wire, such as number 12 American wire gauge, would violate the code and could compromise the safety of the electrical system. The reasoning behind this requirement is to ensure that the grounding conductor has sufficient capacity to safely carry fault current back to the source, allowing the overcurrent protective device to trip and clear the fault. A smaller ground wire may not be able to handle the fault current, which could lead to overheating, insulation damage, and even fire. In addition to the NEC requirements, it is also important to follow any local codes or regulations that may apply. Some jurisdictions may have more stringent requirements for grounding conductors, especially in areas with high electrical loads or sensitive equipment. It is always best to check with the local electrical inspector to ensure that your wiring is in compliance with all applicable codes and regulations. When installing the number 10 American wire gauge ground wire, be sure to use proper grounding techniques. This includes making sure that all connections are clean, tight, and corrosion resistant. It is also important to use the correct type of grounding connectors and hardware. Never use wire nuts to connect grounding conductors. Instead, use listed grounding connectors or terminals. Finally, be sure to properly identify the grounding conductor. This can be done by using green-colored insulation or by marking the conductor with green tape or paint. Proper identification of the grounding conductor is essential for safety and makes it easier to troubleshoot the electrical system in the future. In conclusion, the inspector is correct in requiring a number 10 American wire gauge round wire for the 30 amp circuit. This is because NEC section 250.122c mandates that the grounding conductor be at least the same size as the circuit conductors. Using a smaller ground wire could compromise the safety of the electrical system. Be sure to follow all applicable codes and regulations when installing the grounding conductor and use proper grounding techniques. Always consult with a qualified electrician if you have any questions or concerns about grounding. To further clarify the importance of proper grounding, consider the following scenario. Imagine that a fault occurs in one of the 1.5 horsepower pumps, causing a hot conductor to come into contact with the metal casing of the pump. If the pump is properly grounded with the number 10 American wire gauge ground wire, the fault current will flow through the grounding conductor back to the source, tripping the circuit breaker and energizing the circuit. This will prevent the metal casing of the pump from becoming energized, which could cause an electrical shock if someone were to touch it. However, if the pump is grounded with a smaller number 12 American wire gauge ground wire, the fault current may not be sufficient to trip the circuit breaker. This could cause the metal casing of the pump to become energized, creating a dangerous electrical shock hazard. In addition, the smaller ground wire may overheat and melt, potentially causing a fire. This scenario highlights the critical role that grounding plays in protecting people and property from electrical hazards. Proper grounding is not just a matter of code compliance, it is a matter of safety. Always take the time to ensure that your electrical system is properly grounded and that all grounding conductors are correctly sized and installed. Furthermore, consider the potential consequences of using an undersized ground wire in other parts of the electrical system. For example, If the grounding conductor for a branch circuit is too small, it could increase the risk of electrical shock from appliances or equipment connected to that circuit. Similarly, if the grounding electrode conductor, which connects the grounding system to the earth, is too small, it could reduce the effectiveness of the entire grounding system. The size of the grounding electrode conductor is determined by NEC section 250.66, which provides a table for sizing the conductor based on the size of the service entrance conductors. It is important to note that the grounding electrode conductor is not the same as the equipment grounding conductor, which is the conductor that runs with the circuit conductors to ground equipment. The grounding electrode conductor connects the grounding system to the earth, while the equipment grounding conductor provides a path for fault current to return to the source. Both conductors are essential for a properly functioning grounding system. In addition to the code requirements for grounding conductors, there are also requirements for bonding metal parts of the electrical system together. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This includes metal conduits, metal enclosures, metal equipment, and even metal structural components of the building. Bonding is essential for preventing voltage differences between metal parts of the electrical system, which could create an electrical shock hazard. The requirements for bonding are covered in NEC section 250.90 through 250.102. It is important to follow these requirements carefully to ensure that the electrical system is properly bonded. Finally, it is important to remember that grounding is not a substitute for other safety measures such as ground fault circuit interrupter protection. Ground fault circuit interrupters are devices that detect small amounts of current leakage to ground and quickly interrupt the circuit. Ground fault circuit interrupters are required in many areas of the home, such as bathrooms, kitchens, and outdoor locations, where there is a high risk of electrical shock. Ground fault circuit interrupters provide an additional layer of protection against electrical shock and should be used in conjunction with proper grounding. In summary, proper grounding is essential for electrical safety. It protects people and property from electrical shock and fire. Always follow all applicable codes and regulations when installing grounding conductors and use proper grounding techniques. Consult with a qualified electrician if you have any questions or concerns about grounding. Remember that grounding is not a substitute for other safety measures, such as ground fault circuit interrupter protection. Use ground fault circuit interrupters in all required locations to provide an additional layer of protection against electrical shock. Always err on the side of caution when it comes to electrical safety. It is better to be safe than sorry. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity is a powerful force and can be dangerous if not handled properly. Be careful and always follow all safety precautions.